What forces caused the tombstones in this graveyard to become nearly illegible? Why did this road become cracked, making for rough travel? And what caused these once sharp bricks in this old building to become dull and bumpy? What forces carved out these unusual pillars of rock? And what gouged out the mile-deep Grand Canyon? What's the fate of this rock that sits at the bottom of this cliff? Where did the soil in this field come from? And how is the soil in these beach dunes different from that in this rose garden? During the next few minutes, we're going to answer many of these questions as we explore the powerful forces of weathering and look at some of the important characteristics of soil. Every day, we experience the weather when we walk outside. Weather is the condition of the atmosphere, but the process of weathering is very different. Weathering is the process that breaks down rocks and other objects into smaller and smaller pieces. Weathering occurs all around us. It's a very slow process that's not easy to observe in action, but its effects can be seen. For example, a few years ago, this building was freshly painted, but over time, the paint peeled, chipped, and fell off the wood as a result of weathering. 30 years ago, this sidewalk was smooth and level, but over time, the forces of weathering caused it to buckle and crack. This iron grate used to be bright and shiny, but over time it became dull and rusty. All objects on Earth's surface, including rocks, are exposed to weathering. There are two major types of weathering: mechanical weathering and chemical weathering. You decide. What would happen if you smashed this rock with a hammer? The rock breaks into smaller pieces. A similar process occurs in mechanical weathering. Mechanical weathering involves the breaking down of rocks into smaller and smaller pieces, but the rocks are not chemically changed. For example, hundreds of these smaller rock fragments were once part of the massive rock above. But over time, gravity pulled them down. They broke apart and were further chipped away via the process of mechanical weathering. The downward pull of gravity is one important agent of mechanical weathering. One of the most amazing agents of mechanical weathering involves plants. Surprisingly, plants have the ability to use their roots to wedge apart rocks, breaking them into smaller pieces. Fluctuations in temperature can also play a big role in mechanically weathering rocks. During daylight hours, the sun heats rocks, causing them to expand, while cooler nighttime temperatures cause them to contract. This repetitive process of expansion and contraction can cause rocks to break apart. You decide. What do you think will happen to this water-filled glass container if we place it in the freezer overnight? The bottle broke. Why? When water freezes, it expands, sometimes with great force. When wedged between cracks in these rocks, water can freeze, expand, and over time force rocks apart in a process referred to as frost action. Freezing and thawing played a vital role in weathering these rocks in Utah. These are just a few of the ways rocks are worn down by mechanical weathering. Let's now look at the process of chemical weathering. The rocks surrounding these geothermal hot springs are being changed before our eyes. Even though you can't see it, chemical compounds in the steam and water are altering the rocks in a process called chemical weathering. Chemical weathering is quite different from mechanical weathering. In chemical weathering, rocks are broken down in a process that actually changes a rock's chemical makeup. It's a common occurrence, and water is the agent most responsible for chemical weathering. For example, when rainwater mixes with carbon dioxide in the air, an acid called carbonic acid is formed. Carbonic acid has the ability to alter many rocks, such as calcite, marble, and limestone, breaking them down chemically. This process played a major role in weathering this marble tombstone. Rocks and metals containing iron rust via a type of chemical weathering called oxidation. In the process of oxidation, oxygen in the air combines with iron in a rock or a piece of metal containing iron to form iron oxide, also known as rust. You decide. What is acid rain? Acid rain is snow or rain, which is more acidic than normal. It's formed when certain pollutants, such as sulfur dioxide, are released into the air from burning coal and oil. In the atmosphere, sulfur dioxide combines with water vapor to form dangerous substances such as sulfuric acid. These substances fall to Earth as acid rain. Acid rain is not only harmful to our forests and wildlife, it can also cause chemical weathering of rocks like this limestone, or even damage buildings and statues. Have you ever thought about how important soil is to us? All living things on land depend on soil in one way or another. Most plants grow in soil, and many animals and humans eat fruits and vegetables that grow in the soil. You decide. What exactly is soil? Soil is a mixture of pieces of rock, air, water, and once living things. There are many different things and processes that go into the formation of soil, and there are many different kinds of soil. One of the most important ingredients found in soil is rock fragments. Through the process of weathering, rock is broken down into smaller and smaller pieces. You decide. Could plants easily grow in this gravel? No, plants cannot easily take root, grow, and reproduce in just rock fragments. Plants and other things that live in soil need decomposed material to live on. Humus is made up of once living, decomposed material. Dead plants, animals, and leaves contribute to the formation of humus. Humus tends to be dark-colored, and it provides valuable nutrients for plants and helps retain water. Good, rich soil contains a lot of humus. Soil is continuously forming as particles of rock and humus are added. Soil also contains a great deal of air, which occupies spaces between particles called pore spaces. Water may also occupy pore spaces. Pore spaces are very important to plants because they hold water and gases that plants need. Living things such as bacteria, insects, worms, and even prairie dogs may also live in the soil. Different soils have different texture. Texture is the size of soil particles. For example, this soil in beach dunes has a sandy texture, made mostly of sand. And this soil has a clay-like texture. Have you ever been to a construction site where heavy equipment was digging through the soil and you notice different soil layers? When soil forms, it develops layers called horizons. A side view or cross-sectional view like this one is called a soil profile. Different horizons have different characteristics. Generally speaking, mature soil contains 3 horizons. The uppermost horizon, called the A horizon, is the youngest layer. The A horizon is often dark-colored and contains large amounts of humus. When you work in the soil, such as planting a garden, you're in the A horizon. It's often called topsoil. Topsoil is nutrient-rich and provides needed water and nutrients for plants that absorb them through their roots. Beneath the A horizon is the next soil layer, called the B horizon. The B horizon tends to be a lighter color than the A horizon and contains less humus than the A horizon. Some minerals may wash into the B horizon via a process called leaching. The roots of plants and trees may extend into the B horizon, which is sometimes called subsoil. Lying under the B horizon is the C horizon, the bottom layer in the soil profile. The C layer consists of partially weathered rock, and its composition is similar to that of the bedrock which underlies it. This is a much simplified look at the soil profile. The specific makeup and thickness of soil horizons varies greatly from place to place. The soil in this dry desert is very different from the soil in this prairie grassland. Desert soils tend to be quite dry with limited amounts of humus, whereas the soil here in this grassland is well developed with a thick layer of topsoil. And the soil here in New England is relatively thin and rocky. One of the biggest factors which affects the thickness and characteristics of soil in a region is climate. Drier areas such as deserts tend to have thinner soil than moister climates. Slope also affects soil type. For example, in this region, mountaintops and slopes tend to have very thin soils. But bottomlands in river valleys tend to have much deeper soil profiles. There are hundreds of different soil characteristics and soil types. During the past few minutes, we've taken a look at some of the characteristics and processes of weathering. We explored some of the ways mechanical weathering acts on rocks, as well as some of the characteristics of chemical weathering. And we've looked at the vital role these processes play in breaking down rocks. We also discussed some of the components of soil, including humus, rocks, air, and water. And we briefly explored how soil is formed. We took a look at soil profiles and saw how soil forms layers called horizons. Finally, we took a quick look at how soils differ from each other from place to place. So, the next time you see weathered rocks, dig in the soil around your house or admire flowers growing in a garden, think about some of the things we've discussed during the past few minutes. You just might look at the world a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1 involves the breaking down of rocks. Number 2, gravity is a major agent of weathering. Number 3, rocks surrounding these geothermal springs are being changed. Number 4, rusting involves the process of Number 5, rain can weather rocks. Number 6 is a mixture of rock, air, water, and once living things. Number 7 consists of once living decomposed material. Number 8, spaces contain water and gases. Number 9, soil layers are called and number 10, mature soil tends to have distinct layers.